Where's Dropway talking?
All right, here we go. What's the domain there, Jagger?
The domain 10, 20, 30, 60, 90.
Good. Connor, what's the range?
5, 10, no,
5 is right. What else?
5 and 3.
Range.
Oh my gosh.
5 and,
What, 100?
yeah, just those two. All right.
I'm getting the wrong.
Remember, Y's. Domain X's, range Y's, right? Number 2, is that a relation? Is that a function or not? Does every person in here have one and only one number of pets? Or can you have more than one number of pets? Well, you can have more than one pet, but can you have more than one number of pets? Each person, here. No, you can't, right? You either have 0 or 1 or 2 or 3. You don't have 0 and 2 pets, right? Or 1 and 4 pets, right? Does that make sense? We can all have different number of pets. That's okay, as long as you, right? Every X, you're the X. Number of pets is Y. That's it, right? You can't have 2 different number of pets. You can have 2 different pets, but that would make 2 pets. So that is a function. How about, does every city have one and only one zip code? Or are there big cities that have more than one zip code? Yeah. So that is not a function. It's still a relation. It's just not a function, okay? How about number 4? What's the domain, Marcus? Four to what? Yeah. So the domain is from -4 to 4. There's -4 to 4, right? Remember, that's the X values. Jacob? Edwards? What's the range? Right. It goes from -3 to 3. You guys see that? Remember, that's your Y's. So we use Y for that one. Okay? All right, just looking at what's our possible X values this way, -4 to 4. And then what are our possible Y values this way? That's our range, -3 to 3. Okay? And then number 5 was like 3, 6, and 9 on your homework. So we'll just go over those. Number 3, there was, some extra problems, but it wasn't too hard. You're just substituting the number in for W. So when you put 0 in, you get square root of 5. When you put 2 in, you get 3. When you put -2 in, you get 3 again. When you put 4 in, you get the square root of 21. When you put r plus 1 in, you get r squared plus 2r plus 6. So you're just going to go r plus 1 times r plus 1 because you had to square it. And that gives you r squared plus 2r plus 1, and then you got to add the 5, so that's where the 6 came from. And then if you put -c in there, you get c squared plus 5. Okay? So you're just substituting in to the original function they gave you. Number 6, every answer is 5 except D. All right? It says t of x equals 5. So no matter what you put in for x, the answer is 5. But D had t of 3 plus t of 1, so it's 5 plus 5, which would be 10. Okay? I guess that was it. Those like that, 3 and 6. Number 9 was a piecewise function. Let's look at that one. There's the interval notation. There's Set-Belver notation, depending what it said. All right. This was number 2. I don't know why we had that in there, but let's do this. I think I had number 9 in here, maybe. Thought I got rid of that. There we go. Guess I don't. Okay, number 9 was a piecewise function. Okay? I think it was P of X for piecewise. Okay, so just so we understand this, 3x plus 1 negative x squared plus 11. So I had 2 pieces. And it tells us what the domain is for each piece. If x is less than 2, or this is probably greater than or equal to 2, I imagine. Yeah. Okay, so you had to find P of negative 4. So where does negative 4 fit? Less than 2 or greater than or equal to 2? Less than 2. So I put it in the top one. I go 3 times negative 4, negative 12 plus 1 is negative 11. Okay? Part B was P of the square root of 5. Not F, sorry. I'm used to using F for my function. Well, if you look at the square root of 5, it's like 2.2. All right? So that fits there, right? 2.2 is bigger than that. So I go in this one, negative, and then put square root of 5 in place of the x squared plus 11. So what's the square root of 5 squared? 5. That makes it what? Negative 5. So what's negative 5 plus 11? 6. You see how that's working? Workman? Mather? Don't zone out on me. P of C was the next one. And it said C was less than 2, so that fits in this one. So you're just putting C in place of the X. You're going to 3 times C plus 1, which is just 3C plus 1. That's all you can do. Okay? Because it told you C was less than 2. That's how we knew it would go in there. And then the next one was P of K plus 1. And it said, thanks, Justin. And then it said, K was greater than or equal to 1. So if it's K is 1 or bigger, if I put a 1 in there, what's 1 plus 1? 2. So it's like P of 2, which fits in the bottom one. All right? So we're going to put this right there. So that's negative, and then K plus 1 squared plus 11. Again, since K was 1 or bigger, if I put K of 1, it makes it P of 2, which fits in the bottom one. Now, when you square this, that means K plus 1 times K plus 1, which means you got to FOIL it, right? K squared first, outside 1K, inside 1K, last 1. So it's K squared plus 2K plus 1. And then plus 11. So what's 1 plus 11? Oops. What did I forget? What do I got to do to this answer? No, if I factor, I go back there. What's in front up there? The negative. So all these become negative. All right, so it's negative K squared minus 2K minus 1. So what's negative 1 plus 11? 10, right? So this answer would be negative K squared minus 2K plus 10. So that's how you do number 9, that piecewise one. Number 12, is that a function? Yes, I told you yesterday, if it's got an x and a y, no exponents, it's a line, that's a function. Number 15, you got the square root of x in there, they got that plus or minus, that means the y is going to have, the x is going to have 2 different y values, because the plus and the minus, so no, that's not a function. Number 18, with an absolute value, no matter what x is, it's positive. Negative 2 or positive 2, I put in there, I still get the same same answer, so, remember those look like V's or upside down V's, so that would be yes, it is a function. So 12 is yes, 15 is no, 18 is yes. 21 is yes, you don't see any repeats for x's. And 24 is also yes, again, same reason, no repeats for the x. Each x had one and only one y, so they were functions. Questions on that? Any of those? Eaton, you get all those right? Good. All right, so today, same kind of stuff. Oh, there's number 9 already. Okay, so, and the rest of those. All right, so it says graph that function. You guys know how to plot points, don't you? That's all you got to do. If they give you a set of ordered pairs, you just plot the points to graph it, and you don't have to connect them because it didn't give us an equation or a function. All right? We didn't define the values between them. So you guys should be able to graph some points. I think that's all for that slide. Yeah. Okay. When we do that, you can put in your calculator if you want, or make an XY table like we did last week. We went over this a little bit. Okay. 2 times -1 is -2 plus 1 is -1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. Now you can connect them because it's an equation. Okay, an equation form or function form. Okay. My domain would be all real numbers. All right, when we do absolute value, again, you can use your calculator. Where's the ABS at? For absolute value, how do we get there on our calculator? Let's clear those. How did I get the absolute value? I showed you last week. Guess you're going to have to do an XY table by hand then. What, Jacob?
I don't want to do that.
You don't want to do that? Nobody remembers? Nobody in here? Yeah, go to math. Thanks, Renita. Then you got to move over to numbers. Just move over 1. And that first one's ABS. That's for absolute value. So just hit that, and then x minus 1. Close it off. So you just told the calculator the absolute value of x minus 1, and then hit graph. There are V's, remember? We did it last week also. Okay? But you could always do an XY table, right? If you go second table, you got some points there. Let's do it this way. All right, so -2, 3. I think it's -2, 2, -1, 2, 0, 1, 2, 0. No, that wouldn't be right. If I put -2 in here, that's -3, absolute value is 3. -1 minus 1 is -2, absolute value is 2. 0 minus 1 is -1, absolute value is 1. 2 minus 1 would be, or 1 minus 1 would be 0, that's right. And then 2 minus 1 would be 1. 3 minus 1 would be 2. 4 minus 1 would be 3. So there's our V. Okay. Graph a piecewise one. Okay. So n of x equals 2 looks like what? Like y equals 2. That's the same thing. What kind of line is that? Yeah, good. Straight line. What else? When there's no x in it. Jacob? Close. Yeah. Yeah, horizontal. Okay, if there's no X in it, just a Y like this, it's horizontal through that number. So we have that line. That's n of X equals 2. All right? Now, it says if X is less than or equal to 1. So, should I have kept going at 2, 3, 4, 5, 6? No, I shouldn't have. Okay, I got a little ahead of myself. So I need to get rid of this part. Back to the 1. Okay? And it says including the 1, so that's like, oops. I should have a dot right there. That's where it starts. So at 1, it's 2. At 0, it's 2. And all these, it's 2. Because all those numbers are less than or equal to 1. Okay? N of X equals X, or Y equals X, when I'm greater than 1. Okay? So, if Y equals X, if X is 2, what's Y? If they're equal. 2. If X is 3, what's Y? 3, right? So, 2, 2, oops, that's wrong. I did 2, 3 there, didn't I? When X is 2, Y is 2. When X is 3, Y is 3. When X is 4, Y is 4, 5, 6, 7, 8, 9, 10. Okay? And then back here at 1, when X is 1, it's actually 2. So right here I put a circle. And those would be all these. So that's what that graph looks like. That piecewise. The circle means not including 1, 1. When it's actually equal to 1, the answer is 2. All right, but when it's 1.1, then it's 1.1. When it's 1.5, it's 1.5. When it's 1.999, it's 1.999, right? They're equal. So that's what that graph looks like. Again, if you want to do this, what was it? Y equals 2. We got to delete, let's just clear that. Y equals 2 was this one. And Y equals X was the other one. Oops. And then graph. So you'll see both of them. You just got to figure out where you stop and separate them. Okay? So you can use your calculator to help you do that. The domain tells you the X values, remember? These are our domains for these two graphs. So it lets you know where to start and stop. Does that make sense, what I'm saying? Any questions on that? All right, vertical line test. Yesterday I said all straight lines, all lines are functions except the one that went like this, remember? Okay, so that's what we call the vertical line test. You can look at any graph and in your mind draw vertical lines through the graph. And if I only hit once, if I only hit once, weird, it's a function. Because every X has one and only one Y. If it hits more than once, like the circle we talked about yesterday, the parabolas that open left and right, they don't pass the vertical line test because every X has more than one. Just about, they don't have one and only one Y, they got 2 or more sometimes, depending on what it is. So that's not a function, okay? So is this a function? Yes. Is this a function? No, right? So yes, no. Is this a function? No. If I drew one right there, if I drew a vertical line there, I hit it in 2 spots, right? Now, what if one of those was a circle? then it would be, right? Because the circle means we're not including that spot, right? So this was a no. What about this one? Does that pass the vertical line test? That's a yes, okay? So the vertical line test is a real quick, easy way to figure out if you've got a function or not, okay? If it only hits once, yes, it's a function. If it hits more than once, no, it's not a function. All right? Increasing, decreasing, constant functions, okay? Left to right, like you're reading a book. Increasing would be going this way. Decreasing would be going this way. Constant would be flat. That makes sense? Okay? So from here to here is decreasing. From here to here, it's constant. And then from here to here, it would be increasing. Does that make sense to you guys? So you're going to be asked maybe for the domain of when it's increasing or decreasing. The domain is just the x value. So the domain here would be from, -8 to -3. And then here would be from -3 to 3. Oh, no, that's a 4, isn't it? Sorry. And then increasing here would be from 4 to 10, it looks like. Okay? Now, if those had arrows on the end, that would be from -infinity to 3, right? And if that had an arrow on it, it'd be from 4 to infinity. Again, you can use interval notation as well. Here's the interval notation. Oh, I guess I got the equal to. I can do the brackets. Because we're including those points. So they might ask interval notation. If they say set builder notation, you can just do this. You don't have to do that extra little set stuff and that line and that. So either way, depending on what the directions say, I probably would accept either way because both are right. Okay? If they ask for the domain of increasing, decreasing, that kind of stuff. One-to-one function. Okay? In order to be a function, it's got to pass the vertical line test. If it's a one-to-one function, it means, to be a function, every x has one y and only one y. To be one-to-one, then it means also every y has one and only one x. So it passes a horizontal line test as well. Okay? So the parabola is a function. It passes the vertical line test, but it doesn't pass the horizontal line test. So it's not a one-to-one function. Okay? This one passes the vertical line test. It also passes the horizontal line test. Only hits once both ways. So that would be a one-to-one function. All right? So this one is one-to-one. Passes vertical line test and horizontal line test. Only can hit once. Okay? This is not one-to-one. It passes vertical but doesn't pass horizontal. So again, they'll just ask you that by looking at the graph. They'll give you a picture of a graph and you have to tell that. That make sense? So you can do some graphing today. You can use your calculator to help you. You might have to graph a piecewise function. Okay, like this one. Okay. They'll give you some pictures of graphs and they'll use the vertical line test if it's a function or not. Okay, like this one. Some increasing, decreasing. So just tell, it probably will ask you that for the domain, remember the x values for when it's increasing or decreasing or stuff like that. All right, so there you go. Pretty quick and easy today. You got 15 minutes, you might be able to get done. It's really not that hard. Any questions? Guys are doing a good job. Let's make sure we're taking care of, ooh, a little snow out there. Taking care of keeping our noses covered as well. All right, some of us are letting them slide a little bit.